All right, y'all, so for this I have reaction A. What I'm going to use is a strip of magnesium.
Okay guys, so this is what my magnesium looks like. It's just a silver, kind of shiny piece of metal.
And then what I'm going to do is I'm actually going to heat it up until we see some light.
Okay guys, so this is what it looks like after the lab has taken place. You can kind of see it's white and it's pretty, like if I touch it, it's very powdery and brittle. Alright guys, this is reaction B of the chemical reaction lab. So in this reaction, I'm going to take about 30 milliliters of hydrogen peroxide. I've already poured it out into my graduated cylinder here. You can see it's just a clear liquid. All right, I'm going to pour it into my Florence. Now, Florence just had a little something in it. Now, in your thing it said Erlenmeyer. We chose to do a Florence flask instead. So, go ahead, pour it in. Then I'm also going to add a scoop of Ki. Now, Ki is not actually used in the reaction, but it is a catalyst. Ki is just a white, kind of salty looking powder. Right. I'm going to go ahead and add it to my reaction, and I'm going to stop it if I have time. Alright guys, so that is our reaction. The beaker is now, after the reaction is completed, very hot to the touch. So use that to help you make some observations about what kind of reaction is going on in this lab, as well as what changes or what makes us know that a chemical reaction took place. Cool.
Alright, y'all, so this next reaction, what we're going to do is we're going to take some hydrochloric acid, which is a clear liquid. This is actually 2.5 molar, that's its concentration. And then we're also going to take some zinc. And for this zinc, it is kind of a silvery colored metal. You can see it right there. And what I'm going to do is I'm going to actually mix those together. So I'm going to start with the hydrochloric acid, and I'm going to put about 2 milliliters of hydrochloric acid into this test tube. In terms of these test tubes, a milliliter is about the width of my pinky. So we're going to put about that much right there. And then all I'm going to do is take a couple of these zincs and drop them in there. And then I'm going to take this test tube, I'm going to put it on top of here like this. And then Miss Teresa is going to assist me, and we are going to actually light it on fire. All right? So.
So as you can see, this reaction, obviously it's producing a lot of gas. So we are going to use this wooden splint to do a splint test to help us identify the identity of the gas. So Mr. Oglesby is going to hold that test tube over for a little while to make sure we catch enough of the gas, and then we'll do our splint test.
All right, y'all. Now as a part of this reaction, what we're seeing is there's again lots of bubbles. There's some condensation towards the top of the test tube here, but then it's also getting very, very warm. And so those are some, I guess, observations that you would make as part of this.
Alright, hi guys, this is part D of our chemical reactions lab, and in this one I'm going to take sodium phosphate, and sodium phosphate is just a clear liquid, and I'm going to add it to my test tube, and I'm also going to mix in cobalt chloride. So cobalt chloride is kind of a pinky liquid. Alright, and I'm just going to mix them together. See what happens. So I'm going to start with sodium phosphate. Quite a bit in there so y'all can really see the reaction. And I'm just going to add a few drops of cobalt chloride. What you should be seeing there, guys, is that we see that we kind of formed a purple, and it almost looks like a jelly-like solid in our chemical reaction. So kind of a purple jelly-like solid. There's no temperature change on this one, just the formation of that purple solid. All right. Hey guys, it's Miss Treese here with reaction E, which stands for ethanol. Not really, but that is what we're using. So this is ethanol. This is a type of alcohol. And we're gonna set it on fire and see what happens. All right, let's do it. So some observations that you may not have been able to make, but that reaction actually got very hot. And also there's a little bit of water left at the table as well now after doing that reaction. So there's some water left there. All right, those are some observations that you might have made if you had done this in class.